So in this video, we will talk about higher order partial derivatives. So just how we have a first and a second partial derivative, we can have multiple partial derivatives like the second derivative, the third derivative, all that other good stuff. So the notation is kind of weird. So if I wanted to take the first partial derivative, we knew that it was, with respect to x, it was f sub x. The first partial derivative will be with respect to y. And now we have multiple second derivatives. So second derivatives can be given to you in many different ways. So one of them is that you can take the second partial derivative with respect to x. So this is the second partial with respect to x. That's what that guy means. You can also have the second partial with respect to y. Okay, so you can have something that looks like that, f sub yy. I like saying it like that, f sub yy, f sub xx. And then you can also have these other two, f sub xy and f sub yx. And these are what we call mixed partials, because you have a mix between x and y. And you'll see that these guys are going to be actually equal to each other. I kind of am ruining it for you, but you'll see that both of these guys are actually going to be the same. So, well, given some conditions. So here, what I wrote here is this kind of complicated stuff to kind of scare you, but they're kind of what I just said, right? So again, if you want to write it as how I wrote it right now, f sub xx, f sub xy, all that stuff, you can write it like this. If you want to write it in more like the lateness notation that we used before, you can write it like this. Like this if you were looking at z, or like this if you were looking at f. And what I have here in the very front, and I think this kind of confuses some students, is that f sub xx basically means is that you're taking your first derivative with x and you're taking another derivative with x. F sub xy means that you're taking the derivative with x, the derivative that you took with x, now you're taking the derivative with y. F sub yx means that I'm taking the derivative that I took with y, and then I'm taking the derivative with x. And then f sub yy, I use the derivative that I got from y and take another derivative with respect to y. Okay, so the easiest way to kind of do this is just to do a problem. So let's do this example. So find the second partial derivatives of the following guy. All right, so let's first start off with the first partial derivative with respect to x. All right, so with respect to x, we're only looking at all the x values, and we're holding everything else constant. So the derivative of this guy would just be 3x to the squared, because that guy is good. This guy, you can see that the y cubed is constant, so the y cubed stays there. And I'm going to take a derivative of x squared, which is going to be 2x. There's a plus there. This last guy, you can see that it's a y. I'm taking the derivative with x, so that means that guy goes away. Okay, so it stops. So this is just my final answer for my first derivative with respect to x. All right, now let's find the first derivative with respect to y. So that means I'm going to do this thing over. And now I'm going to take the derivative with respect to y. So with respect to y, this guy clearly is going to go away. So that guy's gone, 0, because it's a constant. All right. Now this guy, the derivative with respect to y, well, that guy is just going to be 3y squared. And obviously the x squared is just a spectator. It's not really doing anything, because we're focusing on y. And then the other guy clearly only has y, so we're just going to get minus 4y. So my first partial with y is going to be 3x squared y squared minus 4y. It's going to be that guy. All right, now we're not done because we want the second partial derivatives. So we're going to now take the derivative of this guy, f sub x, and now what I'm going to do is I'm going to take another derivative, but now with respect to x. Okay, so I'm going to use the thing that I got in green to take the derivative again with x. So what I'm going to get is the first guy is going to be 6x Now notice y cubed is going to stay as a constant. and the derivative of 2x is just going to be 2. So this guy's going to be the second derivative with respect to x. Okay, and now we're going to look at f sub y. So what I'm going to do is I'm going to use f sub y, the one that I have in black, and I'm going to take the derivative again with respect to y. And in this case, notice that the 3x squared is going to stay by itself because it's just a constant, and the derivative of y squared will just be 2y minus the derivative of 4y, which in this case is 4. So f sub y equals 6x squared y minus 4. Okay, now we got 2 down. Now we got to work with the other two, the mixed partials. Okay, and remember that the mixed partials are a little bit weird. Okay, so now what I'm going to do is I'm going to take this green guy, right, with respect to x. Okay, I'm using this green guy. And instead of taking the derivative with x, I'm going to now take it with respect to y. So that guy, you're going to, instead of doing it with x, I'm going to take the one that I have in green and take it with respect to y. So I'm only going to look at all the y's. Notice that this first guy is not a y, so that one's just 0. Here, the 2x is a constant, so that guy's going to stay the same. And now I'm going to take the derivative of y cubed, which in this case is 3y squared. So f sub xy, the mixed partial, is going to be 6xy squared. And now what I'm going to do, I'm going to take the other mixed partial. Okay, I'm going to color that, I don't know, brown. So I'm going to take this black one, f sub y, and what I'm going to do is I'm going to take the derivative now with respect to x. So I'm going to take the mixed partial. So what this is going to give me with respect to x, I'm going to have this guy, 3x squared. That's going to give me a 6x. I'm going to leave that y squared because y squared is a constant, so nothing happens to it. And now remember, we're taking the derivative with x. The derivative of negative 4y is going to go away because it's a constant. And this is what we get. And as you can see, these two guys are exactly the same. So whenever we take mixed partials, these guys are the same. And Clairaut's theorem right here just tells you that they're the same. So there's a theorem that was proven. So as long as f is defined on a disk that contains this point, so if it contains a particular point, like when I plug in 1, 1 or whatever, in this case it's continuous, so it should be fine, then these guys are always going to be the same. Okay. So that's really nice. So when we do these problems and I ask you for f sub xy and f sub yx, well, you don't need to do it because you know they're going to be exactly the same. So let's just do one last problem. So here we don't want all of the second partial derivatives. We just want one of them. And in particular, the only one that we want is f sub yx. Okay. So we have this function. The first thing that we got to do is take the first guy, which is f sub y. So let's look at whatever f sub y should be. So in this case, we're going to look at the first guy. We're only going to look at y. Y is a 1. Okay, so the derivative of y is 1. And notice that e to the x is just a spectator. It's just a constant, not doing anything. Minus, now we're going to take the derivative with respect to, we're still with y. So x in this case is still a constant. The derivative of ln of y is just 1 over y. So f sub y is going to be equal to e to the x minus x over y. Okay, so that's f sub y. Now, that's not what I want. What I want is f sub y, but then what I'm going to do is take this guy, the one in green that we just figured out, and take the derivative with respect to x now. Okay. So I'm going to take e to the x. E to the x is going to just be e to the x because that's a derivative of e to the x. Okay, and remember we're taking it with respect to x minus the derivative of this guy. So this over y is just a constant. So all we got to do is take the derivative of x. The derivative of x in this case would just be 1. So this would be the mixed partial derivative of this guy.